System Testing Methodology, a comprehensive guide. Introduction. Testing system functionality is the backbone of reliable software development. It's the critical process that ensures your application not only works as intended, but can handle real-world conditions and user interactions. This comprehensive guide walks through the 6 essential testing methodologies that form the foundation of robust software quality assurance. 1. Unit testing, building blocks of quality. Unit testing forms the foundation of your testing pyramid. Think of it as examining each individual Lego block before building your masterpiece. In unit testing, we isolate individual functions or components and verify they perform correctly with specific inputs and produce expected outputs. The process. Input, specific test data or parameters. Function, the isolated code component being tested. Output, expected results that validate correct behavior. Side effects, monitoring for unintended consequences like file modifications, database changes, or I/O operations. Key tools. Popular frameworks like PyTest for Python, JUnit for Java, and Mocha for JavaScript make unit testing accessible and efficient. These tools provide assertions, test runners, and detailed reporting capabilities. Best practices. Write tests before or alongside your code, test-driven development. Aim for high code coverage while focusing on critical business logic. Keep tests fast, isolated, and deterministic. Use descriptive test names that explain the scenario being tested. 2. Integration testing, ensuring harmony between components. While unit tests verify individual components, integration testing ensures these components work together harmoniously. It's like testing whether different sections of an orchestra can play together in perfect sync. The architecture. Integration testing typically follows a hierarchical structure where Module A connects to subcomponents B1 and B2, B1 further branches into B1C1 and B1C2, B2 connects to B2C1 and B2C2. This layered approach helps identify interface issues, data flow problems, and communication breakdowns between different system parts. Testing strategies. Big bang integration, testing all components together at once. Incremental integration, gradually combining and testing components. Top-down, starting with high-level modules and working down. Bottom-up, beginning with low-level components and building up. Key tools. Postman for API testing, SOAP UI for web services, and Selenium for web application integration testing provide robust platforms for integration validation. 3. System testing, the complete picture. System testing evaluates your entire application as a unified whole, ensuring it meets all specified requirements and performs reliably in realistic conditions. This is where you verify that all modules work together seamlessly to deliver the intended user experience. The ecosystem. System testing involves testing the interaction between Module 1, 2, 3, and 4 working as a cohesive system, all integrated components functioning as intended, end-to-end user workflows and business processes, system compliance with functional and non-functional requirements. Testing dimensions. Functional testing, verifying features work as specified. Performance testing, ensuring acceptable response times and resource usage. Security testing, validating data protection and access controls. Usability testing, confirming user-friendly interfaces and workflows. Compatibility testing, ensuring operation across different environments. Key tools. Selenium for web applications, Appium for mobile testing, and specialized tools like LoadRunner provide comprehensive system testing capabilities. 4. Load testing, stress testing your system's limits. Load testing simulates real-world usage patterns to understand how your system performs under various traffic conditions. It's like stress testing a bridge to ensure it can handle rush hour traffic without collapsing. The simulation. Multiple users, represented by user icons, simulating concurrent access. Application under test, the green blocks representing your system. Performance metrics, measuring response time, throughput, error rates, and resource utilization. Testing scenarios. Normal load, expected daily traffic patterns. Peak load, maximum anticipated user volume. Stress testing, beyond normal capacity to find breaking points. Spike testing, sudden traffic surges. Volume testing, large amounts of data processing. Key metrics to monitor. Response time and latency. Throughput, requests per second. Error rate and failure points. Resource utilization, CPU, memory, disk I/O. Scalability characteristics. Key tools. Apache JMeter, Gatling, and LoadRunner provide powerful load testing capabilities, while cloud-based solutions like Locust offer scalable testing environments. 5. Error testing, preparing for the unexpected.
Error testing, also known as negative testing, evaluates how gracefully your system handles invalid inputs, unexpected conditions, and failure scenarios. It's about building resilience into your application. The assault strategy. Service A and B, different system components under attack. Latency assault, testing response time under stress. Exception assault, triggering and handling unexpected errors. Kill app assault, testing system recovery from crashes. Testing approaches. Input validation. Invalid data types, formats, and ranges. Boundary testing. Edge cases and limit conditions. Error recovery. System behavior after failures. Security testing. Malicious input and attack factors. Key benefits. Improved system reliability and user experience. Better error messages and user guidance. Enhanced security through input validation. Reduced production issues and support costs. Key tools. Gremlin for chaos engineering. Tools for fuzzing and penetration testing, and specialized error injection frameworks help systematically test error conditions. 6. Test automation. Efficiency and consistency at scale. Test automation transforms repetitive manual testing into efficient, consistent, and scalable processes. It's the assembly line of software testing, ensuring quality while reducing time and human error. The automation pipeline. Commit change. Developer commits code to repository. Trigger build. Automated build process initiates. Build. System compiles and packages the application. Run test. Automated test suites execute. Notify outcome. Results communicated to the development team. Automation benefits. Speed. Tests run faster than manual execution. Consistency. Same tests run identically every time. Coverage. More comprehensive testing possible. Efficiency. Frees up human resources for exploratory testing. Continuous integration. Seamless integration with CI/CD pipelines. Key tools. CI/CD platforms, Jenkins, Travis CI, Circle CI, GitHub Actions. Test frameworks, Selenium, Cypress, Playwright for web testing. Mobile testing, Appium, Espresso, XUTI test. API testing, Rest Assured, Postman, SOAP UI. Best practices for automation. Start with stable and repetitive test cases. Maintain a balance between automated and manual testing. Design tests for maintainability and readability. Implement proper reporting and logging. Regular maintenance and updates of test scripts. Strategic implementation. Building your testing strategy. Start small. Begin with unit testing and gradually expand. Prioritize. Focus on critical business functions first. Automate wisely. Automate stable, repetitive tests. Monitor and measure. Track test coverage and effectiveness. Continuous improvement. Regularly review and update testing approaches. Integration with development process. Shift left. Integrate testing early in development cycle. Continuous testing. Automated testing throughout CI/CD pipeline. Risk-based testing. Focus efforts on high-risk areas. Collaborative approach. Foster communication between developers and testers. Conclusion. Effective system testing requires a multi-layered approach that combines these 6 methodologies. Each layer serves a specific purpose in ensuring your software is reliable, performant, and user-friendly. By implementing comprehensive testing strategies using the right tools and methodologies, you build confidence in your software's ability to serve users reliably in real-world conditions. The key to success lies not just in using these testing methods, but in adapting them to your specific context, maintaining them properly, and continuously improving your testing approach based on lessons learned and evolving requirements. Remember, testing is not just about finding bugs, it's about building confidence in your software's ability to serve users reliably in real-world conditions.